When we began this series, all we had in our hands was a black, sharp, and primitive piece of stone, obsidian. At the dawn of human history, we depended on it to survive. Then we melted it in fire, turned it into beads and ornaments. We blew the breath from our lungs into it and made goblets, made art. For centuries we struggled to flatten it, turned it into windows for our homes, and finally let the light in. Throughout history, glass had a simple role: to be a still, hard, and transparent barrier, to protect us from the wind while showing us the view, to hold water while revealing what's inside. A passive, silent, obedient material. But if you think the story of glass is over, if you believe glass belongs only in buildings, kitchens, and museums, you are deeply mistaken. The real story is just beginning. Today, glass is undergoing a silent revolution. It is no longer just a passive material. It no longer only transmits light. It now transmits information. It thinks, it reacts, it has memory, and it connects the world here. We have reached the final stop of this four-part journey, stretching from the Stone Age to the Space Age. Today's topic is the place where sand turns into silicon, and silicon turns into intelligence. Welcome! How are you hearing me right now? How did this video reach your screen in seconds? Most of us imagine the internet as something in the air, in the cloud, or wireless. We picture Wi-Fi signals flying around us. But this is a grand illusion. The internet is not in the air. The internet is underground, at the cold, dark bottom of the oceans. And this vast network connecting the world is made neither of copper nor gold. The internet is made of glass. The story actually begins long ago. In 1870, Irish physicist John Tyndall was performing an experiment on stage in London. He pierced a hole in the bottom of a water tank and shined a light behind it. As the water flowed out in a curved arc, everyone expected the light to travel straight and hit the wall. But it didn't. The light was trapped inside the water. It bent and flowed downward with it. That day, Tyndall proved something remarkable. If light is trapped inside the right material, it can be guided. Yet it took humanity 100 years to use this idea. Until the mid-20th century, we connected the world with copper cables. But copper had limits. Electrical signals weakened over distance, cables heated up, and they couldn't carry much data. In the 1960s, engineers asked a radical question again. What if we sent data not with electricity, but with light? Nothing in the universe travels faster than light. But how do you trap light inside a cable? Light travels straight. Cables bend. How do you make light turn corners? The answer, once again, was glass, but not window glass. Scientists produced glass fibers from pure silica, thinner than a human hair. This glass was so pure that if the oceans were made of it, you could see the seabed thousands of meters below from the surface. This is what we call fiber optics. The working principle is mesmerizing. A laser beam is sent into this glass thread. The light hits the inner walls of the glass, but because of its structure, it cannot escape. It reflects inward, toward the center, over and over again. In physics, this is called total internal reflection. The light bounces millions of times inside this microscopic glass tunnel, traveling at the speed of light for kilometers without losing energy. Today, the 1.3 million kilometers of fiber optic cables lying on the ocean floor are the nervous system of our world. When you type "hi" to someone or open this video, that command doesn't travel as electricity. It becomes a beam of light, bounces inside that thin glass at the bottom of the ocean, crosses continents, and reaches you. We are literally communicating through glass. Without glass, there would be no internet, no Netflix, and smartphones would be nothing more than calculators. The digital age we live in is, in truth, a technological age of glass. The wonders of glass didn't stop at connecting the world. Using glass, we managed to see not only far away, but also into the past. How? Through telescopes. Glass bends and refracts light. Once humanity realized this, we first made eyeglasses to correct faulty vision. Then we stacked lenses and saw invisible microbes. But the greatest revolution came when we turned those lenses toward the sky. When Galileo looked at the moon through his first telescope, glass quality was poor. Today, however, humanity's greatest eye, the James Webb Space Telescope, uses massive gold-coated beryllium mirrors and ultra-precise lenses. These mirrors are so smooth that they can capture even the faintest light from the darkest corners of the universe, light that has traveled billions of years. Think about it. A photon, a particle of light, travels for millions of years through cosmic darkness and finally strikes the glass we created. Thanks to glass, we can look back to the infancy of the universe, to just after the Big Bang. A lens made from sand lets us witness the birth of stars. Without glass, we would never know our place in the universe. We would be staring into blind darkness. Now let's return from the depths of space back to Earth, into the palm of our hands. Glass didn't just shrink the world under oceans or in space. It came into our pockets, to our fingertips. Statistics show that a modern human touches their phone an average of 2,600 times a day. Think about it. We don't touch our loved one's hand 2,600 times. We don't touch our own face that often. For most of the day, our fingers rest on cold, smooth glass. But when smartphones were first designed, engineers faced an impossible problem. Plastic screens scratched and dulled. Glass shattered at the slightest impact. A glass that wouldn't break when dropped was thin enough to feel touch and clear as crystal. That defied the laws of physics at the time. Legend has it that in 2007, just before the first iPhone launched, Steve Jobs noticed his keys scratching the plastic screen of a prototype. He got angry. "I need glass," he said. "Glass that doesn't scratch." The solution came from an old experiment developed in the 1960s and shelved as useless. Corning had created a glass called Project Muscle, but no one cared. Until that day. What we now know as Gorilla Glass is produced through a chemical bath, a kind of chemical wizardry called ion exchange. The glass is submerged in molten potassium salt at 400 degrees Celsius. A molecular battle begins. Small sodium atoms in the glass surface are pushed out by heat. Their place is forcibly taken by larger potassium atoms from the salt. Imagine removing slim people from an elevator and forcing giant sumo wrestlers inside. What happens? Extreme compression and pressure. That atomic compression on the glass surface hardens it like armor, creating a tense outer layer. This is why that thin glass can resist drops and even hammer blows. Glass is no longer just our window. It is our interface to the world. We no longer control the world through glass, but on glass. So what's next? What else can glass do? In the future, glass will completely abandon its passive role and become an active device. Scenes once confined to science fiction are now reality in laboratories. The first step, electrochromic glass. Curtains will become obsolete. Apply a tiny electric current to your window, and the molecules inside align. The glass darkens. Too much sun? Press a button. The glass becomes sunglasses, blocking heat and reducing energy costs. Want the view back? Press again. It turns transparent. Even more exciting, data storing glass. Hard drives fail. CDs decay. USBs get lost. Humanity is running out of places to store its data. With projects like Microsoft's Project Silica, scientists now etch data into glass using lasers. A palm-sized quartz glass plate can store 360 terabytes of data, and it's immune to water, fire, and magnetic fields. Not for 10 years, not 100, but for millions of years. Humanity's knowledge, music, and history could be locked inside tiny pieces of glass forever. Glass may become the black box of civilization. And finally, bioglass. Glass is revolutionizing not just technology, but our bodies. Doctors have developed a special glass that mimics human bone. It can replace broken bones or decayed teeth. The body doesn't reject it. It accepts it. Over time, the glass dissolves and turns into bone. In the future, glass won't just be in our hands. It will literally be inside us. We've reached the end of this 4-part journey. Looking back, what do we see? An extraordinary transformation. It began with a black, sharp stone spat out by volcanoes. Humans held it in fear and turned it into spearheads to survive. Then they melted it, shaped it, drank from it, and built civilization. They flattened it, made windows, tore down walls, and let the light in. Finally, they turned it into hair-thin fibers, trapped light inside, and connected the world. Isn't it strange? From spear tip to fiber optic cable, from skyscraper facades to phone screens, it's all the same thing. All sand. That worthless silicon beneath our feet. when combined with fire and human intelligence, becomes the most versatile material in the universe. Look around you today. Your computer screen, your drinking glass, the cable carrying the internet, the city skyline. We are not living in the Iron Age or the Space Age. We are living in the age of glass. And the most beautiful part, for thousands of years, we shaped glass. Now, glass is shaping us, how we see, how we communicate, how we live, and what we will remember. The story of glass is not over. The furnaces are still burning, and that grain of sand will continue to shine. Thank you for watching.